Welcome students. So we'll be solving a lot of questions on probability distribution, both on discrete probability distribution and continuous probability distribution, so that you are able to understand this topic very thoroughly, and you are able to solve the questions in examination. So this is a very important lecture. You must listen to whatever I am saying very carefully. First of all, what is the difference between, or what is the relation between probability theory and probability distribution? Many students find it very confusing. So let me explain this by giving you an example. We have a coin and we toss it for 4 times, or let's say 3 times only. We toss a coin 3 times. Then, according to probability theory, what is the probability of getting head? Exactly 1 number of times. See how we do this. We have a coin. When we toss, the probability of getting head is 1. Let's say our desired outcome is getting a head. So the probability is 1/2 of getting head. Then Q is 1/2. That is the probability of not getting a head. Clear? This is the probability of getting head. This is the probability of not getting a head. So if we toss a coin once, our probability is 1/2 of getting a head. If we toss for 3 times, the question is, what is the probability of getting head exactly, let's say 2 number of times? How we do this? We do this by binomial theory of probability, which states that the probability of getting exactly r number of successes out of n number of trials is NCR p to the power r q to the power n minus r. This is our binomial theory of this is from binomial theory of probability. Clear? So right now what I asked what is the probability if we if we toss a coin 3 number of times, that is n is 3, what is the probability of getting exactly 2 number of heads, that is r equal to 2. So this is our question. What will be the answer? Let's say we write it like this: P2, this is 3C2 1/2 r, that is 2, and then 1/2 n minus r, 3 minus 2 1. This is factorial 3 factorial r, that is 2 factorial 3 minus 2 1. This is this is 4 and then 2 8, so this is 1/8. This is 3 factorial 2, we cut it, so this is 3/8. So the probability of getting head 2 number of times, exactly 2 number of times, is 3/8. So this is our probability theory. Probability theory. We have used binomial theorem to get the probability. What is distribution? Now understand the relation between this theory and distribution theory. This is for r equal to 2. What if we want to find for r equal to 0? That is probability of not getting head when we throw the coin, when we toss the coin 3 number of times. What it will be? It will be r equal to 0. So for r equal to 0, what is the probability? It will be, I am writing it first of all, for r equal to 1, r equal to 2. So we have found for r equal to 2, it is, the probability is 3/8. Let's see what is this for r equal to 0. For r equal to 0, this will be 3C0 p to the power r, that is 0, q to the power n minus r, 3 minus 0, 3. So this is factorial 3 factorial 0 factorial 3 1/8 2q. So this is 1/8. So the probability of not getting any head in the 3 number of times is, what is it? 1/8. Getting head 1 number of time, exactly 1 number of time. This will be, this is 1, this is 1, this is 2. So this is factorial 3 factorial 1 factorial 2, and this will be 1/8. 2 square then 2. This is 3 into factorial 2, so this cancels. Again, what is the answer? 3 by 8. 3 by 8. So r equal to 1, this is again 3 by 8. And what is the probability that every time we get head, we toss the coin for 3 number of times and every time we get 3. So that will be 3C3, 1 by 2, 3, 1 by 2, 0. Why we are getting this always, every time we are getting 1 by 8? Because the probability is half and probability of not getting also half, because these are same, therefore the result is same. If these two are different, this result will differ. So this is factorial 3, factorial r, factorial n minus r, that is 0, and 1 by 8. So this is 1 by 8. This is our probability. From probability theory we are able to calculate the exact probability, and when we have distributed it like this, it is probability distribution. So it is written like this, or now I am rubbing this. Generally it is written like this, r or x, anything you can write x also. So 0, 1, 2 and 3, and the probability associated with this is 1 by 8, 3 by 8, 3 by 8, 1 by 8. Clear? So by probability theory we were able to get the value of, we were able to calculate the value of probability for particular variate 0, 1, 2, 3, and when we have arranged it like this, variate is 0, 1, 2, 3, the probability associated with each variate is written. This is called probability distribution. Now this is discrete probability distribution. You know why? Because it is for some discrete values. If it was the number of values was infinite, if it was from 0 to 3, each and every value, if the variate could have taken any value between 0 and 3, that is 0, 0.1, 0.111, 0.1, that would have been a continuous distribution. Since it has taken discrete values, it is discrete probability distribution. So now you understand how from probability we are able to get the probability distribution. Now what we will do, we'll revise some important formula, along with that the concepts also, by which we will be able to find certain constants from this distribution, like what is the mean of this, what is the variance, what is the standard deviation, and so on. So when you will have a question, you will have, this is a good question, that we toss a coin 3 number of times. What is the mean of the distribution? So from theory of probability we are able to find the distribution table, and now we will find the particular constant that we want to, like mean variance. So up till now it is clear. Now I will discuss some other concepts. Now I have written that distribution over there, so that after discussing the concept we will calculate from this distribution table also. What we need to know? We need to know mean. We need to calculate mean. What is mean? Mean is given as mu1 dash. What is it? In a probability distribution, what you need to do is you have to simply take p into x, or if you write it like this, I equal to 1 to n. This is that pi into xi you do for the complete distribution, and you will get the mean. Clear? Just keep these in mind so that you are able to solve questions. Second thing is variance. What is a variance? Variance is given like this, and this is actually mu2. That is the, what is mu2? If you remember, mu2 is the second moment that we take. It is given as, see, fi into xi minus the mean square of mean, and this is 1 by n, I equal to 1 to n. This is the formula of mu2. If you are getting confused, you should go to the video where in probability and statistics you will find it in probability and statistics playlist. There, go to this playlist, you will find video on moments. So check that video and you will understand how this is equal to this. Okay, for our purpose I am shortening your effort. What you need to do is this fi 1 by n of this is essentially equal to simply summation of this into x minus the mu is the mean. This is equal to this. Or what you can do is, if you remember, mu2 is given by mu2 dash minus mu1 dash square. This is the formula. Now you know what is this. This you have calculated. You need to know this so that you are able to calculate this. What is mu2 dash? Mu2 dash is simply pi into xi square. This is pi, this is xi. I is 0, 1, 2, 3. So here what you did, pi xi. You got mean about the origin. This is about origin. If it was about certain arbitrary constant, it would have been like this. But what we are doing is, we are taking it about the origin, so that a is equal to 0. So pi xi is mu1 dash. So mu2 dash is pi into xi square. Similarly, it is xi minus a whole square, but a is 0, therefore pi xi square. So you can take this value from there, put it here. This is this minus this. You will get variance. Clear? And the standard deviation is what? It is simply root of this. Clear? So we will be using this to get mean and variance of this distribution. So the mean mu1 dash is sigma pi xi. What is the meaning? Adding all, that is pi is 1 by 8 into xi, p1 into x1, then p2, that is 3 by 8 into x2, plus p3 into x3 plus p4, sorry, p0, p1, p2, p3, so 1 by 8 into 3. What is this? This is 0, this is 3 by 8, this is plus 6 by 8 plus 3 by 8, 8, 8, 8. So this is 6 plus 6, 12, 12 by 8. That is 3 by 2. So our mean is 3 by 2. I am writing it here, 3 by 2. Now, what is variance? Variance is, before taking variance, let's find out mu2 dash. Mu2 dash, I told you, this is pi into xi square. Clear? So I'm doing it. Pi, that is 1 by 8, xi is 0, 0 square is 0, then 3 by 8, 1 square, that is 1, plus 3 by 8, 2 square, plus 1 by 8, 3 square. This is 0, this is 3 by 8, this is 2 square, 4, 4, 3, 12, 12 by 8, this is 3 square, 9, 9 by 8. So this is 9 plus 3, 12 plus 12, 24 by 8, that is 24 by 8 is 3. So we got our mu2 dash, this is 3. And what we have to find? We have to find variance. Variance is mu2. And mu2 is, as I told you, mu2 dash minus mu1 dash square. From where I have got this formula? From the chapter on moments in probability and statistics. So now let's put it. Mu2 dash is this 3 minus mu1 dash square. Mu1 dash is this 3 by 2 square. So this comes to 3 minus 9 by 4. What is this? 12 minus 9 by 4, and this is 3 by 4. So our variance is 3 by 4. And if you want to know what is the standard deviation, it is root over 3 by 4, because this is sigma, so you can write this as root 3 by 2. Clear? I have started from probability. Then what I did, I calculated the probability distribution, and then now I have calculated the mean, mu2 dash, sigma square, SD, etc. Clear? So what I'll do is I'll solve 4 or 5 more questions so that everything gets into mind and we are able to solve questions in examination. Okay, our first question. We are given with a probability distribution, a discrete probability distribution, xi minus 2, minus 1, 0, 1, 2, 3. Okay, and the probability associated with these variates is 0.1, k, and these all. What we have to find? We have to find what is the value of k, we have to find what is mean, and we have to find what is variance or standard deviation, whatever you say. So how we will do? Let's see. I have told you just now how to solve this. First of all, we will have to find the value of k. We know that sigma pi, if we add all the probabilities, this will be equal to 1. This is very clear. In continuous distribution, what we say, from infinity to minus infinity to plus infinity, if this is the function is fx, the probability function, this has to be 1, and in discrete this is equal to 1. So this means this plus this plus this plus this plus this plus this is 1, that is 0.1 plus k plus 0.2 plus 2k plus 0.3 plus k is equal to 1. So this is k, 2k, 3k, 4k. So 4k plus 336 plus 0.6 is equal to 1. This means k is equal to 0.4 by 4. 1 minus 0 is 4. So this is 0.1. So our k is equal to 0.1. This is the first value. So we have got our k, that is k is equal to 0.1. Let's put 0.1 in place of this so that we are able to solve it more, efficiently. 2k. So this is 0.2, k again 0.1. So now our distribution is like this. Okay. You can see 1, 1, 2, 4, 6, 9, 1. So this is equal to 1. Now it is correct. We have to find first of all mu1 dash, that is sigma pi xi. This is mu1 dash, that is this into this. So this is 0.2 minus 0.2 minus 0.1. This is 0, this is 0.2, this is 0.6. Okay, and this is 0.3. So what we get? This and this cancels. This is 0.6, 0.3, 0.9 minus 0.1, that is 0.8. So our mean is 0.8. Okay. This is our mean. Let's find out mu2 dash, that is what? Pi xi square. So pi 0.1 into this square, this is 4, plus 0.1 into this square, that is 1, this is 0, I'm leaving it. This is 0.2 into this square, that is 1, this is 0.3 into this square, 4, plus 0.1 into this square, 9. So what it is? 0.4, 0.1, 0.2, 1.2, 0.9. So what it is? See, 0.5, 0.7, 1.6, 1.8. That is 1.6 and 1.8. This is 2.8. So our mu2 dash is 2.8. Okay. Now we have to find mu2, that is our sigma square. This is mu2 minus mu1 square. So this is 2.8 minus mu1 dash. Mu1 dash is 0.8. Square will be 0.64. Clear? So this is now 2.8 minus 0.64. So it is 2.16. See, 16 and 8. So the variance is 2.16. Clear? And if you have to find the standard deviation, you can take this. Clear? So this is how we solve question. We have our distribution like this. We have to find the standard deviation. Standard deviation sigma. So let's start solving. We know first of all we will have to find mu1 dash, that is the mean. Then we will find mu2 dash, and from there we will find variance. So mu1 dash is what? Sigma PIXI. Clear? So this is this into this. 1 by 8 into 8 plus 1 by 6 into 12 plus 3 by 8 into 16 plus 1 by 4 into 20 plus 1 by 12 into 24. This is PIXI. So this is 2, 5, 2, 2. So this is essentially 1 plus 2 plus 6 plus 5 plus 2. So this is 3, 6, 9, 9 to 11, 16. So our mean is 16. This is mean. Okay. So our mean is 16. Now mu2 dash. It is, now I'll do this by two ways so that you are able to understand it in a better way. What I'll do, first of all I'll take PIXI square, then mu2, what I'll do, mu2 will be mu2 dash minus mu1 dash that we are using. What I can do, I can directly take mu2 also. How? Because we have our mean. So pi into xi minus mean square. So and we'll see if we are correct or not. Let's first of all go by this method. So this is 1 by 8 into xi square. 8 square, that is 64, plus 1 by 6 into 12 square, that is 144. 3 by 8 into 16 square, 256, plus 1 by 4 into 20 into 20, 400, plus 1 by 12 into 24 into 24, whatever it be. Clear? Let's calculate. This is 2 times, so this will be 48. Here 100, 8, 3, 162, so this is 32, 32 into 3, 96, plus 6, 2, then 24, 6, 4, 20, so this is 24, 8. So this is this, what is this? 24, 8, 32, 32 and 48, 80, 80 and then 100, 180 and 96, that is 276. So this is our 276. Clear? So we have got our mu2 dash 276. Therefore mu2, that is our variance, is equal to mu2 dash minus mu1 dash square. So mu2 dash is 276, mu1 dash, what is it? 16. 16 square is 256. So what we get? 20. So our variance is 20. Variance is 20. What will be our standard deviation? It will be under root 20, or what we can say, this is 4 cross 5, So this is 2 root 5. So our standard deviation is 2 root 5. This is the answer. Now, for better understanding, what I am trying to do is what I told you just a few minutes, when we are solving the question. From the definition of moments, we know that mu2 is sigma pi into xi minus mean. Mean is here this whole square. This is the direct definition of mu2. From this definition only we were able to use the, find out this formula. So just let us verify. Pi 1 by 8 xi minus mu1, that is 8 minus 16. 8 minus 16 square. Clear? So this is 864 plus 1 by 6. Now 12 minus 16 square. 12 minus 16 is minus 4 square, minus 4. So 4 4 16. 3 by 8. 16 minus 16. So moment about mean is 0. We know this. Then 1 by 4. 20 minus 16, that is 4 square 16 plus 1 by 12. 24 minus 16 square, that is 8 square 64. 8 8 64. Clear? So this is 8. This is what? 4 2 2 3 8. So this is 8 by 3. This is 8. This is 8 by 3. This is 0. This is by 2. Okay, this is 4. Sorry, sometimes you get stuck. So this is 4 16 3. So this is 16 by 3. Now you can see this is 8 plus 4 12. This is 8 by 3 16 by 3. So this is 16 plus 8 24. 24 by 3 is 8. 12 plus 8, that is 20. So we get mu2 as 20, which is this. We found mu2 as 20 from that equation also. So just, you can go directly also. Instead of getting mu2 dash and then all formula, you can go directly also. Whatever suits you, you can try. So we have got our result. The standard deviation is equal to 2 root 5. Clear? Now our question 3 is it is a very good question. It says we have a basket in which we have 3 red balls. Red and 2 white balls. A person has to take out 2 balls at random without replacement. You have to take 2 balls. Now if you get a red ball, you will get rupees 20, and if you get a white ball, you get rupees 10. So if you get 2 red balls, you will get 40. You will get 2 white balls, you will get rupees 10 only. Sorry, 20 only. The question is, how much amount can the man expect? What is the expectation? What is expectation? Expectation is mean. In terms of continuous frequency distribution, probability distribution, you say it expectation, and for a discrete probability distribution, you say it mean. So actually the question is we have to find mean. Clear? Let's see how. So basically we have to find the probability. Let's say probability of finding 0 red balls. When we took 2 balls from here and the number of red balls was 0. What is it? How will get? That is, out of 3 red balls we get 0 red ball, and both balls are white. That is 2 cross 2 C 0 2 3 0 2 2. And total out of 5 we have taken out 2 balls. This is how we calculate the probability. That is 3 red balls, 2 white balls. We took 2 balls out. The probability that both balls are white, that is the probability that the number of red balls is 0. How we calculate? 3 0, that is out of 3 0 into out of 2 2 by out of 5 this. This is how we calculate probability. So this is what? 3 0 is 1 into 2 C2 is again 1 by 5 C2. What is 5 C2? Let's say what is 5C2? This is 2 and this is 3. So this is 5 cross 4, then becomes 3, 3, 3 cancel. This is 2, 2, 2. So this is 10. So it is actually 10. So the probability is 1 by 10. For 0, this is 10. So I am writing it here properly. Let's say R 0, the probability is 1 by 10. I am creating the distribution table. Now, probability of one red ball, it will be 3C1 and 2C1 because one red ball, one white ball, by same 5C2. 3C1 is 3 factorial 1 factorial 2 cross factorial 2 factorial 1 factorial 1. It is factorial R n minus R. Clear? By 10. This we know is 10. So what is this? This is 3, 2. So this cancels. This is 2, 1. Okay. So this is 3 into 2, 6 by 10. So the probability is 6 by 10. Probability of getting one red ball is 1 by 10. Now let's see what is the probability of getting two red balls. It is 3C2. When you get both balls as a red, this will be 2C0 by 5C2. So this is, what is it? Factorial 3, factorial 2, factorial 1. This is 1 by 10. So this is 3. This is 3 by 10. So 2, 3 by 10. Then let's see what is it. What is the value for P3? 3C3. This is again 0. Sorry. Oh, we have to take two balls only. So no 3. The variety is only for 0, 1 and 2. Okay. Yeah, probability also you can see 6 plus 1, 7 plus 3. That is 10 by 10, 1. So this is done. This is a probability distribution table. Now we have to find mean. See, let's see what is the value of amount that we will get. If this is 0, that is both balls are white, two whites. So how much amount we will get? For one white ball we get 10. So this is rupees 20 in rupees. This is one red and one white. So 20 plus 10, 30. This is both red. So this is 40. So these are the possibilities that if this is the case, that is none of the balls is red, we get rupees 20. If one is red, one is white, we get 30. If both balls are red, this is 40. So what will be the expectation? That is the mean. So what we will do? Instead of this, we'll multiply by this pi into xi and we'll get our mean. That is expectation. What is it? P into whatever rupees we get for that probability. This is the amount into its probability. So this is 20 into 1 by 10 plus 30 into 6 by 10, 40 into 3 by 10. 3 by 10. What are we doing? The probability of getting rupees 20 is 1 by 10. Here what it is? The probability of getting 0 red balls is this, which is equal to probability of getting rupees 20. So we are getting mean of this distribution now, from where we can have the expectation. So this is 2, 6, 3, 18, 4, 3, 12. So this is 32, that is rupees 32. So this is the expectation. So if we have such arrangement, what you can expect is rupees 32. This is a fair expectation. Okay, clear?